Hello everyone. Today we are going to see maximum subarray sum. So now coming to the question. Given an array of an integers and we have to find a subarray for which that subarray sum should be the largest compared to any other subarray that can able to generate from that array. Given an input array which is of -2 followed by 1, -3, 4, -1, 2, 1, -5 and 4. So subarray is nothing but a some portion of the array which is being continuous. So that comes under the subarray. And the length of the subarray can be ranges from one element to the length of the array element. So here I'm just denoting the variable as n, which means nothing but the array length. That is array dot length. Coming to the normal approach, we just wanted to generate all the possible subarrays and wanted to find the summation of each possible subarray. That is -2 is a part of the subarray and -2, 1 followed by -2, 1 and -3. Try to generate all the possible subarrays and at every step try to find the summation of that subarray and so like that with -2, 1, -3 so on up to thing. So extending the logic in a clear fashion, our intention is we have been trying to generate all the possible subarrays. And now for that particular subarrays, we just wanted to explore all the things. Now say previously generated all the possible subarrays when we are standing at -2. Now assume we are just standing at 1. Then the all possible subarrays of 1 is 1, 1 comma -3, so on up to 1 comma the ending length of the array. And here you'll be calculating the summations of everything. So like that you'll be keeps on continuing for -3 when it gets started and so on up to 4. So here comes at the end you'll be ended up with the 4. And one observation I wanted to make here is like the array is of the length 9, so you'll be getting 9 subarrays. You'll be getting 8 subarrays, 7 subarrays, so on up to 1 subarray. So in a short, you'll be getting n of n minus 1 divided by 2 subarrays. Sorry, it's n of n plus 1 divided by 2 subarrays. Now, coming to the brute force approach, just like we have generated these things, now we're just looking in a code format in generating these subarrays in a clear fashion. Now, showing you the brute force approach. We just wanted to pick a start pointer at the thing and we just wanted to pick an end pointer also here and being we are just generating a subarray that is been starting from the ending, that is array consisting of the starting element and also the ending element. So the ending keeps on traversing in the forward direction. So when the ending start is being placed at the 0th index, let me just write it down the indexes of the arrays. And when the ending is at the 0th index, then the array that actually generated is -2. And when the ending is been moving forward direction, then the array that is being generated is -2, 1. But however, for this problem sake, we are more focused on summation compared to subarrays. So if the ending is been keeping the starting at 0th position itself, and if you can able to traverse the end at each other iteration, then you will be able to generate the subarray by varying the length in an increasing direction. And to generate the next set of the subarrays, you just wanted to move the starting pointer, and you wanted to make the end pointer that should be equals to the starting pointer, and you wanted to traverse the end pointer in the forward direction. So like this. So with this part, you'll be generating the next set of the subarrays that is actually been starting from 1 like this. And if you wanted to move the start pointer, and here it's the next point of the subarray, so you'll be getting the subarray of 3. And at the end, you'll be getting the subarrays that is being started with -3 and ended with the last element, which is a 4, like that. So programmatically, I just wanted to show you in a simpler fashion. Given an array, and whenever you just got an array, it would be good if you can calculate the length of that array. So here the length, I was usually denoting n variable for the length. So n will be the length of the array, and our intention is to find the maximum value of the subarray. First of all, we wanted to generate all the possible subarrays. How can you be able to generate this one? As I said, just wanted to fix the start pointer at the start and wanted to make the end pointer that should be starting from the same position. So we just fixed the start pointer at 0, and now the end pointer starting position is same as the start pointer starting position. So that's what I wanted to mention here. From the start pointer to the end pointer, now we will be having an index. Let's take the end is been at the starting itself, and maybe end has been moved to some other location. Now what we'll be doing was we will be using one more pointer which is known as k, that has been started from the starting position, yes, and this k will be keeps on adding the element which is at the starting position up to the element which is at the ending position. So you can observe here the starting and ending one will be acting like a ranges of the minimum range and the maximum range up to which the range of the indices we wanted to have the subarray. So that's where the starting and ending index will be coming into the picture. So to count the summation of each and every element, we actually need a variable known as sum. So here we are more focused on a subarray that is being of -2, 1, -3, 4, because we just gave the range from 0 to 3 indices. And I just wanted to make initialize a summation which is of 0. So that's what here in the code we wanted to make. You just wanted to initialize the summation as 0. And when k is been standing at the 0th index, you wanted to add that starting index. And let me just close the brace. And if you see, the k keeps on getting to the next place. And now the summation value will be keeps on changing like -2, and now it's of -1 since 1 has been added. And here -3 has been added, so it's been -4. And when k has been moved to this position, it has been added with the 4, so the value will be 0. And now coming out of this loop, you just found the entire summation of this subarray. So this subarray sum has been found, and now you wanted to store this subarray sum in a maxi. Like You just found a subarray with the sum is nothing but 0. So that's what the code has been represented here. So one thing I wanted to say was, since it's a programmatic thing, in a mathematical you don't need to initialize any kind of variable. It would be good if you can able to initialize the maximum variable. So usually we will be initializing the maximum variable with the least value as possible, such that any value in an array that can be treated as a maximum value. So that's the reason we just initialize the maximum value as the least value. Assuming the max value is nothing but the least value, let's say minus infinity, something like that. Now you wanted to store the maximum value comparing the newly generated sum and the existing maximum value. So which is nothing but maximum of these two. So immediately max value will be getting updated to 0. So that's what we will be writing. We will be mathematically comparing the existing max value with the summation, such that whatever the max value that will be there, usually the sum will be there. So at the first time, so that will be stored as a max value. So now the max value is of 0, and for this particular subarray you just got a maximum value. And now what will happen is, you just found the max value for this particular subarray. Now our end pointer keeps on moving forward, and again there will be a k pointer with summation is being initialized to 0. Summation initialized to 0. Again, the k pointer keeps on moving from the starting index to the ending index. Since the previous sum, so the entire sum is of -1. So here again we are just traversing the loop. Then the end pointer moves forward. The k should be traversing from the starting position to the ending position. So which is nothing but, again it's been generating the summation which is of 1. So like that, this iteration keeps on going. However, this will help you in having a time complexity which is of O of n cube. The reason it is of O of n cube, you can assume the entire step at max it will be running was O of n, and the end pointer itself has to traverse n steps, and the starting pointer is been moving. When all the end steps of the end pointer has been completed, the starting pointer will start moving one step ahead. Like that, the starting pointer should be moving completely out of that loop. That is, starting pointer should reach up to here. So even the starting pointer will be iterating through the end times. So eventually, this is nothing but O of n cube. So that's a brute force algorithm. One observation I wanted to make, as a human, while I'm calculating this sum, again and again, if I know the sum of the range from here to here, which the summation value is of 0, when I moved my end pointer from here to here, again I'm not focusing on calculating this summation, this one, this one, this one, this one, which obviously I know the value has been 0. So whatever the newly generated value is there, I'm just taking that value and adding that one to the previous sum. So plus of -1, that is nothing but -1. So when you know the summation up to here, there's no need, no point of again traversing from the first position to the last position. So with the next position itself, you can able to traverse the things. So that is the suboptimal approach.